A very good morning, students. In today's class of 19 HGB 204 biomass conversion, we are going to study about biomass characterization. So, content in this presentation is biomass composition, biomass properties, and proximate analysis, ultimate analysis, and heating value. So there are four main groups or compounds present in biomass. Number one is water, number two is inorganic compounds, number three is extractives, non-structural compounds which can be leached using solvents, are sugars and starch, lipids, waxes and resins, proteins and peptides. And finally, cell wall. So it is the structural compounds consist of hemicellulose, cellulose and lignin. Biomass properties. So usually biomass is divided into or can be characterized by physical and chemical properties or proximate and ultimate analysis. So before going to physiochemical properties of biomass, so these are the essential reference for are required for design and implementation of pre-treatment of biomass as well as conversion technology or conventional conversion process. So physiochemical properties are density, flowability, grindability, particle size, moisture absorption, moisture content, ash content, volatile organic matter, elemental composition, energy content, thermal properties and chemical composition. So these are required for these are the design parameters or handling parameters for transportation and conversion efficiency of each biomass conversion technologies can be dealt by using these properties. So because of that we have to study these properties. So number 1, physiochemical properties. So physical properties, density. So as we all know, density is nothing but mass by volume. So the particle and bulk in designing the logistic system for a biomass handling and transport. So density should be found, and here as it is a biomass, so we'll study the bulk density of biomass. Thermal conductivity and specificity. In thermochemical processes, biomass are subjected to heat and conduction across and along their fiber. Morphology, particle size and sphericity, affecting the mixing, surface area for heat transfer and the fellow behavior of biomass particles. So the chemical properties of biomass can be found using proximate and ultimate analysis. 4 bases of analysis commonly used for expressing biomass analysis results as received basis based on the total sample as it arrives at the laboratory and prior any pre-treatment. Air dried basis, so based on the condition in which the sample is in equilibrium with atmospheric humidity, it neglects the presence of moisture other than inherent moisture. Dry basis, based on the condition in which the biomass is free from moisture or the completely moisture is removed from the biomass, is the dry basis. Dry ash free basis, based on the condition in which the sample is considered free from all moisture and ash. Proximate analysis, it is the determination of weight percentage of moisture content, volatile matter ash content, and fixed carbon. So these are expressed in ASTM standards. Water content, it is an important property in thermochemical conversion. Water has to be evaporated except in hydrothermal process, and it requires latent heat. So weight sample is heated at 105 degrees Celsius in a hot air oven for at least 3 hours but not longer than 72 hours. Weighed after cooling in a desiccator for 30 to 40 minutes. So the heat will be reduced completely when we use the desiccator. The process is repeated until its weight remains unchanged. Freely available water is equal to water available above equilibrium concentration. So bound water is equal to total moisture content minus free water. Is the water bound to the cell wall constituents. Next is ash content. So ash is the incombustible solid mineral matter in fuel, the inorganic remnant after combustion. It mainly contains of oxides of silica, aluminium, iron, calcium, magnesium, titanium, sodium, and potassium. Measured by combusting the dried biomass sample in a muffle furnace at 575 degrees Celsius plus or minus 25 degrees Celsius for 3 hours. Cooled and weighed, followed by further 1 hour at until the sample varies by less than 0.3 milligram from previous weighing. So this also should be cooled in a desiccator. High levels of alkali and alkaline metals, higher concentration of chlorine lead to deposition of corrosive ash in biomass fired boilers. Properties of biomass ash is helpful to predict the tendency to form deposits in the boiler components and composition of char produced in pyrolyzer and gasifier. Volatile matter or volatile organic matter. So the condensable vapor and permanent gases exclusive of water vapor released from biomass when it is heated. The dried biomass sample is put in a covered crucible to avoid contact with air during devolatilization in an inert atmosphere. Then the covered crucible is placed in a furnace at 950 degrees Celsius and heated for 7 minutes. Later, the crucible is taken out and cooled in a desiccator and weighed. The weight loss due to devolatilization is the volatile organic matter present in the biomass. According to Chauhan and Shah, a higher volatile content implies increased amount of bioal production from pyrolysis. Fixed carbon. The solid combustible residue that remains after biomass is heated and volatile matter is expelled. And it is determined as fixed carbon is equal to 100 minus ash minus moisture content minus volatile matter. So this is an example of different carbonaceous materials. Coal with different ranks: anthracite, bituminous, lignite, coke, peat, anthracite. So it falls between 40 to 100% fixed carbon weight. And here the typical biomass concentration of fixed carbon and volatile matter falls between 20 to 40. For example, rice straw, cotton stack, wheat straw, corn stack, pine, poplar, and sugar cane. So this is the proximate analysis of different biomass are being given. So the maximum from Jatropha cake. So 4725 calorific value is obtained from Jatropha carcass or Jatropha cake. So this can also be found using an instrument TGA analysis or thermogravimetric analysis of biomass or any organic compound can be found. It gives a continuous record of weight loss of the sample being heated, and it can be used to predict optimum pyrolysis temperature ranges and expected char yield. It can be used to perform proximate analysis. So at different temperature, so what is the weight loss will be given. So from that we can find the composition of the given biomass. Thank you.